Hi, welcome to Math 2 Unit 1 Worksheet 4 Homework Help. Today we're going to be looking at several problems here dealing with radicals. So we're going to zoom in on some of these here and take a look. So here we go. Taking a look at number 2, beginning there. Lots of ways to approach these. I'm not sure how your teacher instructed you. It's just kind of how I go about doing it when I work with radicals. One of the things I'll do is I'll take a radical and just kind of break it apart almost like to a factor tree. So for example, 24 can be factored into 2 times 12. 12 can be broken down into 3 times 4. And 4 can be broken down into 2 times 2. So once I've factored it down all the way, then what I like to look for is I look for pairs of numbers. So for example here I have 2 2's. And when I find 2 of the number, like this, I know that I can put these 2 2's, which is really a 4, and the square root of 4, right here, square root of 4 is actually equal to 2. So once I have 2 of the 2's, or 2 of any number, I know I can put it outside the radical. Now what I have left here is I have a 3 and I have a 2. Those are still inside of the radical. So I have a 2 and a 3, and I can then multiply them back together to discover that I have 2 root 6 as a solution set for this one here. 2 root 6. So you could do a factor tree and kind of look for those groups. If you got to the 4 and went, oh, I know square root of 4 is 2, you're set there. So as you're kind of going through these today, just keep in mind some basic ones. If you know the square root of 4, that's a good one that comes up quite a bit. Square root of 9 is going to come up quite a bit as well, so you could just stop at a 9 if you wanted to. You might see a square root of 16, which is 4, and a square root of 25, which is 5. And of course your number 1, where you started with square root of 36, which is 6. So these are some simple ones you could look for and just kind of stop the factor at that point. Take a look at number 3 real quick. So I do the same process here. 60, I could break that apart into, depends on how you see it. I could take it and make it a 10 and a 6 because 10 times 6 is 60. I could break that apart into a 2 and a 5 and break the 6 apart into 2 and a 3. Again, I look and I have 2 of the 2's in my tree, so I can put that outside the radical because I have 2 of them. Remember, I'm only putting 1 of them there. Even though I have 2, I'm only putting 1 out there. And what do I have left inside? I have 5 times 3, and 5 times 3 is 15, and so that's what I have left under the radical. So I have 2 root 15 for my solution here. Let's look at number 5. 5 is a weird one. Whenever I see really funky numbers like this, I usually go, well, there's probably a reason they gave me this number. It probably does break down into something, just not sure what it is. In this case, I just thought I'd try a 3 and see what happens, and sure enough, 3 times 49 gives you 147. So that's the breakdown there. Now if you know your square numbers, 49 is a square number, right? 7 times 7 is 49. So I could break it apart if I chose to and write 7 and 7. Either way, we're going to put 7 outside the radical, and we still have a 3 under the radical here. So we have 7 root 3 for an answer for number 5. Let's move over to number 12. On number 12, we have plus or minus 9, and then root 120. Again, same thing here. I'm going to break apart the 120. I'll break it apart the way I see it first. I see this as 12 and times 10. No problem, 12 times 10. I'll break that apart again. I have a 4 times 3, and over here I have a 2 times 5. Again, if you remember what we already know about the radicals, the 4 is already, square root of 4 is 2, so I could put that on the outside. Now the trick of putting it on the outside now is I have already a 9 on the outside, right? I have this 9 right there. So I already have a 9, and now I'll multiply the 9 by the 4. I put the 4 on the outside, and then under the radical I still have a 3 times a 2 times a 5 because I can't break those down anymore. At this point I'm going to multiply things together. So 9 times 4 is 36, so I'm going to keep it as plus or minus 36, and then 3 times 2 is 6, times 5 is 30, and so I end up with 30. Oops, got to do a little correction real quick. Sorry about that. See, with the 4, what's the square root of 4? The square root of 4 is 2. Oh, my mistake. Sorry about that. So we put a 2 there. And then I got to go back and go, oh, 9 times 2 is 18. So if you were catching that while I made the mistake, sorry about that. That's what happens when you start doing one strategy and switch it up a little bit. Alright, the square root of 4 is 2. So we have 8 plus or minus 18, square root of 30. Oops. Alright, it's okay. Number 14. We have 4 root 6 and then square root of 27. Okay, so if I want to write this out a different way, I could think of it this way. I could think of this as 4 times the square root of 6 times the square root of 27. I could think of it like that. So the 6 can become a 2 and a 3. 27 can become a 3 and a 9. And a 9, of course, can become a 3 and a 3. I'll keep breaking that down. So now let's look for some pairs. I have 3's right here, which means on the outside of the radical, which I already have a 4, I can add 1 3. Over here I have another pair of 3's, so I can add another 3 on the outside. And under the radical I just have this one little 2, and I'll put that right there. Next step is to multiply things together. 4 times 3 gives 12, and then 12 times 3 is 36, and I still have the root 2. So my answer is 36 root 2. Number 16, similar idea. We have a negative 3 outside. We have a positive 3 right there, so I'm going to multiply by a 3. And the radical stuff, I have an 8, and I have a 32. Let's break the 8 apart. We have a 4 and a 2. Break the 32 apart, and we have an 8 and a 4. We break the 4 apart here, and we have a 2 and a 2. We break that 8 apart, and we have a 4 and a 2. Break that 4 apart, and we have a 2 and a 2. And break that 4 apart, and we have a 2 and a 2. So we have lots of 2's, and we have a negative 3 and a 3 on the outside. So let's put this together. I have a negative 3 times a 3, and let's find some groupings here. Here's one set of 2's, so we'll put that on the outside. Here's another set of 2's, so we'll put that on the outside. Here is another set of 2's, so I put that on the outside. And if we look here, I have this 2 and this 2, so we can put that on the outside. So what's left in the radical? Nothing. There's nothing in the radical. So now I'm going to multiply 3 times 3 times 2 times 2 times 2 times 2 all the way across. And when I do that, I end up with negative 144. Alright? Loads of fun there. So that's why I end up with a solution set for that one. Hopefully I did that one right. A little funky, but there you go. Number 17. Same idea. On the outside I have a 7, and I have a 2. There's that one. And inside the radical I have a 3, and I have a 15. I could break the 15 down to a 3 and a 5. At that point I can see that I have a little partner pair there. So I can put them outside the radical. 7 times 2 times 3. And on the inside I have a 5 still. So 7 times 2 times 3 is 42. And I still have the root 5. So that's number 17. On number 18, I have this negative here, so let's keep in mind we have a negative, almost like a negative 1 on the outside of number 18. I can break apart the 12 into a 4 and a 2, 4 and a 3, and the 4 becomes a 2 and a 2. The 18 can become a 2 and a 9, and the 9 can become a 3 and a 3. And look for those little partners, pairs of 2's. There's a pair of 2's, so I can put that outside the radical. Keeping my negative here, I have a negative with a 2. I have a group of 3's here, so I put that outside. And I still have inside the radical, I still have a 3 and a 2. So 3 times 2 on the inside. So negative 2 times 3 is negative 6. And here 3 times 2 is 6. And so our solution is negative 6 root 6 for number 18. Okay, coming down to the end here, number 22. I have a 5 on the outside. I have another 5 on the outside. On the inside I have a 2. And I have another 2. Well, the 2 and a 2 partner up together, which means they can go on the outside together. So now we have 5 times the 2's on the outside. And 5 times 5 is 25 times 2 is 50. I have 50 for my answer there. And number 23, it's the same idea except it says that it's squared, which just means write it again like this. 3 root 7 times 3 root 7. And in that case here, just like before, we'll have a 3 on the outside. We have another 3 on the outside. And with the radical, I have a 7 times a 7. And again, they partner up together, so no problem. They can now go play on the outside. So 3 times 3 times 1, 7 is going to be 42. Hopefully that helps a little bit, and hopefully I got most of those right. If not, check with your teacher. They know best. Have a great day.